Hello students, I am Dr. M. Mangaleshwari, Assistant Professor, Department of Mathematics. I am here to discuss about the remaining properties of eigenvalues and eigenvectors. Let me first explain what is eigenvector. Let A be a matrix of order n cross n and lambda be an eigenvalue of A, then there exists 0 not equal to x belongs to V such that Ax equal to lambda x. Let me explain with an example. Let A equal to a 2 cross 2 matrix. Let me find an eigenvalues corresponding to the given matrix. So the eigenvalue of the given matrix is lambda equal to 1 and lambda 2 equal to 3. Now corresponding to lambda 1 equal to 1, we are going to find an eigenvector. The eigenvector is found out by A minus I into x is equal to 0. And corresponding to lambda equal to 3, we are going to find out an eigenvector. So, corresponding to lambda equal to 1, the eigenvector is x1 equal to 1 minus 1. And corresponding to lambda equal to 3, the eigenvector x2 is equal to 1, 1. Now, the first property, the eigenvector corresponding to distinct eigenvalues of real symmetric matrix are orthogonal. I repeat the property, the eigenvector corresponding to distinct different eigenvalues of real symmetric matrix is orthogonal. Let me take the previous example. In the previous example, x1 and x2 vector and the given matrix is a real symmetric matrix. So, for that, I am going to check the orthogonality. That is, orthogonality is nothing but x1 transpose x2 equal to 0. So, x1 value what I obtained is 1 minus 1. Now, x1 transpose is 1 minus 1 and x2 is 1, 1. So, the value I am going to get is 0. Therefore, the eigenvector of distinct eigenvalues will be orthogonal. This is the first property. And property 2, the similar matrix have same eigenvalue. We need to know what is similar matrix. Two matrices A and B are similar if B equal to P inverse AB for some invertible matrix P. Let me take an a 2 cross 2 matrix, an invertible matrix P equal to 1, 1, 0, 1. Now I am going to compute B matrix which is P inverse AB. Now I am finding out P inverse which is 1 by determinant of P into HP. Now, computing the value of B equal to P inverse AB, I have reached with a value of B equal to 2 minus 1, 0, 3. Now, I have to show that the matrix A and the matrix B have same eigenvalue. The eigenvalue of A is the matrix which has an upper triangular matrix and the eigenvalues are 2 and 3. And eigenvalue of B is also an upper triangular matrix and the eigenvalue of B is also 2, 3. Therefore, the similar matrix have same eigenvalue. Property 3. If a real symmetric matrix of order 2 have equal eigenvalues, then the matrix is scalar matrix. Let me take an 2 cross 2 matrix 5, 0, 0, 5. This is real and symmetric matrix. Now what it of order 2. What I am going to show is if it has an equal eigenvalue, then the matrix is said to be a scalar matrix. First I am going to determine the eigenvalue. As usual by determinant of A minus lambda I, then 5 minus lambda the whole square. Finding out, I will be reaching with same eigenvalue. Lambda equal to 5, 5. Hence, and now we have an same eigenvalue and the given matrix is also a scalar matrix. Hence, 2 cross 2 matrix has equal eigenvalue. It must be a scalar matrix. For every 2 cross 2 matrix, whatever be the 2 cross 2 matrix, if it has same eigenvalue, then it must be a scalar matrix. Property 4. The eigenvector of a matrix is the eigenvector of a matrix is not unique. Property 5. If lambda 1, lambda 2, lambda n be distinct eigenvalues of n cross n matrix, then the corresponding eigenvectors x1, x2, xn forms linearly independent set. We need to know what is linearly independent set. A set of vectors is called linearly independent if none of the vectors in the set can be written as a combination of others. I repeat that a set of vectors is called linearly independent if none of the vectors in the set can be written as combination of others. So, if there are n distinct eigenvalues, then the eigenvectors are said to be linearly independent. Then the corresponding eigenvectors are said to be linearly independent set. Property 6. If two or more eigenvalues are equal, it may or may not be possible to get linearly independent eigenvectors corresponding to equal roots. Property 7. Two eigenvectors are orthogonal if x1 transpose x2 equal to 0. We have already seen this in a property 1. Two vectors are orthogonal, then if the condition is satisfied, it is said to be an orthogonal vector. Property 8. If A and B are n cross n matrix and B is a non-singular matrix determines that the determinant of B should not be equal to 0. Then A and B inverse AB have same eigenvalues. Thank you.